This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus episode 713. This week we welcome Jim Rosenthal. We're going to talk about air cleaners, filtration, and the popular Corsi-Rosenthal Box. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And after the show, don't forget about afterthoughts.iaqradio.com, sponsored by First On Site. IAQ Radio Plus marquee sponsor is First On Site Property Restoration at firstonsite.com. IAQ Radio Association sponsors are ACGIH, the American Conference of Governmental Industrial Hygienists at acgih.org. AIHA, the American Industrial Hygiene Association at aiha.org. IICRC, the Institute for Inspection, Cleaning, and Restoration Certification at iicrc.org. The Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at eia-usa.org. IAQ Radio industry sponsors are Particles Plus at particlesplus.com, TSI Inc. at tsi.com, Tramex Meters at tramexmeters.com, and Healthy Indoors Magazine at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm sorry to report that no one correctly identified Samuel Johnson as the author of the quotation, "Great works are performed not by strength, but by perseverance." Here's today's IAQ Radio trivia question. Name the standard developed by AHAM, which is the Association of Home Appliance Manufacturers, in the 1980s to measure the performance of air purifying devices. Back to you, Joe.
All right, Jim Rosenthal. He's the chairman and chief executive officer of Tex-Air Filters. He is also a past president of the National Air Filtration Association and a past president of the Asthma and Allergy Foundation of America, Texas chapter. He is the Rosenthal in the Corsi-Rosenthal Box, a hugely popular do-it-yourself air filter. Welcome to IAQ Radio, Jim.
Thank you, Joe. Appreciate you putting me on the show. Looking forward to this session. I think we're going to have some fun.
I agree. Hey, first, let's let our audience get a little bit of your background. How did you end up being the chair and chief executive officer of Tex-Air Filters?
Well, I always wanted to own my own company. I worked for other people started my career in 1972 up until 1994. And I left the company and had a little bit of severance to work with and used that time to developed my own company in 1997. We started with some retail stores selling allergen avoidance products. Those stores were called Allergy and More. We had a website, still have it, allergyclean.com. We expanded the stores. We also bought a little air filter company called AA Tex-Air Filter Manufacturing, had 12 employees. Got our store chain up to 5 and realized that was not going to work. So we did a pivot, as many businesses do, and we decided to go pretty much all out in the air filter business. So since about 1999, we have been an air filter company. We have a factory in Fort Worth, 5 offices and distribution warehouses throughout the state of Texas, and business is good. We've been growing substantially, and I have some free time to do things like play with the Corsi-Rosenthal box. So,
well, how big of an increase in business? I mean, was COVID being in the, in the news as much as it was, the pandemic and all, we had heard that, a lot of indoor air quality people got busy because of COVID. What about the filtration manufacturing world? Did you guys get a big jump in orders when COVID came along?
Yeah, it definitely had a positive effect. What happened was that obviously everything was shutting down for the pandemic. Our customers, many of our customers have technicians that are out working. They couldn't stop working. They needed the filters, so we felt like we had to stay open. So we stayed open. And one of the things we did was we started making masks. We had MERV 13 media, and we got a couple of ladies and set them down on some sewing machines. This was 2020, and masks were very hard to come by, and we made 25,000 masks and gave them away. And how did it affect business? Business definitely went up. I remember getting a call actually from people out at University of California, Berkeley, and they were working with the Department of Defense, and they said, we just got a recommendation from ASHRAE that we need to go to MERV 13 filters. What do you think? And I said, that's a problem, because right now, at that time, that was about 5% of the market, MERV 13 filters. And if you started going through that recommendation, it's going to move it up to about 40% of the market. So for the next 2.5 years, everybody in the filter business had a real battle to come up with the necessary materials to make those filters. But how did it affect us? I mean, it definitely increased business. We had some really good growth years during the pandemic, and we did a really good job. We had great suppliers, and we did a good job of getting the filters to our customers. So that helped us as well.
Yeah, that I've always wondered about that, like MERV 13. It seems like that's kind of the sweet spot. That are they as effective as people think? What are some of the key things people have to know with respect to how they're used if you're going to get that type of efficiency from them?
There was a good study done by Brent Stevens about 6 or 7 years ago. He analyzed filters for virus removal using the Wells-Riley equation, and found that MERV 13 is pretty much the cutoff for a substantial increase in removal, and that pretty much was one of the reasons why we focused on that. Plus the technology was available for pleated filters, which constitutes the majority of filters sold in the United States, majority sold in North America.
And pleated filters are more efficient because of the surface area. Is that accurate to say?
Yeah, it's the surface area gives you more media. That the extra media gives you better airflow, less resistance, and it allows you to have higher efficiency of the media itself. Also increases the media to a certain extent because you slow down what's called the media velocity. The more media you have in a pleated filter, the more you are able to decrease the media velocity, and you have some increase in efficiency.
Interesting. All right, let's talk a little bit about how air cleaners, now instead of just filters, let's talk about air cleaners. Cliff had a good trivia question about the CADR, but I wonder if you could talk to listeners a little bit about how air cleaners are tested.
Well, there's an organization called it's AHAM, the Association of Home Appliance Manufacturers. Yeah, thank you. I always forget that.
Appliance manufacturers.
And there is a prescribed procedure for coming up with what's called the clean air delivery rate, and it's commonly referred to as CADR. And there are three numbers that you come up with. It varies depending upon particle size, but those are smoke, dust, and pollen. And the advantage of having a standard test is that gives you the opportunity to compare one air cleaner versus another. It's not just the filter. As we'll talk about, the airflow is extremely important as well. And CADR gives you a measurement of the overall performance of the air cleaner.
What are the other factors beyond filtration that are important in air cleaners?
So this Corsi-Rosenthal box thing, what we found out, we have the greatest laboratory in the world, because there are probably 200,000 of these things that have been built around the world.
Wow.
And we've got continuous feedback. And the most important things are obviously particle removal. But close to that is noise level. What we found, and people who make HEPA air cleaners as well have found, is that noise is a consideration. It doesn't bother me. It doesn't bother my wife. We've been running air cleaners in our house in the bedrooms for 20 years, and it's just background noise. It's neutral noise, but it bothers some people. And then in classrooms, it is a major consideration. So noise is something to consider. And then also the footprint, how big the air cleaner is, how much room it takes up. Because if you're putting a couple of these in a classroom, space is at a premium. So it's how big of an area that it takes up. And then one of my major points is that it can't add anything to the environment. It can't add anything to the indoor environment. Great air cleaners are pretty simple. They're a fan and a filter, and they will do an excellent job of removing particles from the air. I don't think there's any really good scientific evidence supporting additive air cleaners because of the indoor air chemistry that's possible, that happens when you change the structure of the indoor air.
I've been curious. A lot of maybe not a lot, but some manufacturers add devices to kill bioaerosols that have already been captured on a filter.
Right.
Do captured fibers escape from filters?
Do the viruses escape from filters?
Particles, I guess, in general.
Yeah, and it's theoretically possible. Does it happen? Not that we're aware of. And since the start of the pandemic, there have been researchers working with what they call forensic analysis of filters. They've been trying to come up with any viable virus on a filter. So far, nobody's been able to do it. Zero. So it's okay to kill it, but it's already dead. A virus needs a shell, if you will, that has moisture in it, protein and moisture, or it can't exist. And so when the air is passing over that filter at 500 feet a minute, there's very little moisture almost instantaneously. I mean, the moisture evaporates very quickly. So what's there is there. And Dr. Lindsay Marr had a comment and said, yeah, that filter media is dangerous. If you cut it up and put it rubbed it all over your face, you might get a virus. So, it's a joke, but that's pretty much what we have found, is that killing the virus on a filter is killing something that's already dead.
And I just want to make sure I get through all these background before we get into the Corsi-Rosenthal box itself. But one is, what's new in filter technology? I see a lot of electrically charged filters these days. Can you tell us the pros and cons on that? And if there's anything else new in filter technology?
Yeah, the electret filters, they really go back about 20 years. I mean, they're not necessarily new. But the big thing with electret media is the advantages. It gives you better airflow and higher efficiency on small particles. That's what we'll be talking about quite a bit. It's very important, the higher efficiency on the small particles. And then the disadvantage is that some electret media will decrease in efficiency in use. And that is a consideration, definitely a consideration. And what we have found is that it's a lot less of a problem than people talk about it being.
All right. Cliff, did you want to add something? Or
yeah, actually, we had a text question.
Okay.
Let's see. The text question was: Jim wrote an excellent article about how particulate levels could rival those from a HEPA filter with lower MERV ratings 11 or 13, with or by increasing air change rates across the filter, relative to that principle being coupled to an HVAC system providing 4 to 5 air changes per hour across the filter. I have a question. Is there any literature to answer the question of whether or not individual return intakes, as in each room, provides more reduction in particle reduction versus 1 or 2 central return inlets?
I'm not aware of any. The problem with putting filters on the return vents is that you're increasing the pressure drop. And my experience is that most residential systems do not allow enough return air. They've not made the return air grills big enough, the system big enough at the unit, and you really don't have a lot of extra pressure drop to play with. So you probably could have some increase, and it would be theoretical. But I really think it's a mistake to put the filters at the grill rather than at the unit itself. They're still going through the unit, still going through the filters at the unit. So I think you'd be better off just keeping your system running and then using good filters at the unit.
Thank you.
That'd be my advice.
Let's talk a little more about the Corsi-Rosenthal box, and while we're doing that, we can get into some of these other technical areas along with about filtration. But
okay.
And while you're kind of giving the story of how this began, we're going to play in the background a little video that Jim sent us that shows how many of these things and how many different variations and all over the world where they're coming from. But Jim, tell us a little bit about how this story started.
Okay, it started, I got a call from a reporter from Wired magazine. They asked me to talk about, or to find out whether or not a filter on a fan worked. I said, I don't know, I've heard about it. So I decided that I would use the filters that I had in my factory and go out and buy a fan. Did a study on it. They wrote an article and it said, does this janky air cleaner work? And it does, it did. But Rich Corsi was also interviewed for that article. And he put forth a hypothesis that he had about using multiple filters in a box and saying that it would decrease the pressure drop by having multiple filters. And I thought, man, that's a great idea. The very next day I made one. I called it the Corsi box. And then Dr. Don Milton from the University of Maryland saw it, and he recommended this to be used for the vice presidential debate. It was picked up by the New York Times, and it was called the Corsi box. And Dr. Corsi read the article and he said, it's not the Corsi box. I didn't make it. Rosenthal made it. And so Dr. Milton looks at that comment and he says, okay, it's the Corsi-Rosenthal box. And so that's how the name came about. And when the thing that we decided to do from the start, which is probably the best decision we ever made, was we made it open source. I probably have had, at least 100, maybe 200 people come up to me and say, why didn't you patent this? And the answer is, number one, it wasn't the right thing to do. But number two, if we would have patented it, it would have been a product that maybe had, we sold a few hundred of them and try to work on distribution. And I don't think it would have ever been anything. But by making it open source, it's easy to do, very effective, and everybody accepted this as their project. We've had people all over the world actively coming up with variations of the Corsi-Rosenthal box, making much better air cleaners than Dr. Corsi or I ever could have made. And it just shows that we're smarter as a group than we are individually. And the group has been fantastic. So I think the decision to make it open source was the key, and still open source. Nobody's making money on it. It is there for the benefit of people to have cleaner, safer indoor air.
And now you've got the Corsi-Rosenthal Foundation, a 501c3 nonprofit dedicated to providing cleaner and safer indoor air for all. Tell us a little more about the foundation, Jim.
About 6 months ago, we decided that we needed to have a means to keep the momentum going on the Corsi-Rosenthal box concept. And from the start, our objective was to make an air cleaner that was available to everybody. Make it work and make it inexpensive, make it available to everybody. So the focus of the foundation, it is a nonprofit. The idea is to come up with ways that we can provide cleaner, safer air for all. So we're working with school districts, working with churches, homeless shelters, other organizations where clean air could make a big difference. And the idea is to be able to enable people to do it on their own, to build them, to create them, to continue this open source idea, but provide some incentive to do that through funding for filters and fans and other things that are needed. The school program is actually a curriculum that's been developed. So training people on indoor air and the benefits of indoor air, and then also how to organize. You do one of these builds and you make 20 Corsi-Rosenthal boxes, and it's a bunch of fifth graders. How do you organize people to make Corsi-Rosenthal boxes? I mean, it's a tremendous learning experience. So we're trying to replicate that. There have been a number of people around the world that have done this successfully, everywhere from South America to the Philippines to Fort Worth, Texas to San Diego. I mean, list goes on and on. We know it works, and we know it can be successful. And the idea of the foundation is to just further that success.
Jim, it seems to me this is kind of a fundamental change in air cleaner design. Have you seen any air cleaner manufacturers trying to implement some of the key changes that you've made here, the box design, bringing in air from 4 different ways? Have you seen anybody trying to kind of replicate that in the manufacturing world?
Oh, yeah. I've seen a couple come out that actually have 4 filters in a box with the flow coming out the top. A couple of the major filter air cleaner manufacturers. There's one that they're touting as just revolutionary. That basically it's a fan sitting on top of a cylindrical filter, and guess what? It works. Just as these work for exactly the same concept. So
now, are they using the MERV 13s, or are they using a HEPA filter?
I think they're using HEPA filters of various qualities. Could I go to a couple of slides? I'd like to explain
Do
some
that.
of them. Let's go to number 3 if we can. I've numbered these slides, and gives me a chance to talk about some of this stuff and answer some more questions. One of the questions that we've had is, well, first of all, these are filters that have been in use in our factory and offices, and they're new, 2 months old, 4 months old, 6 months old, and 10 months old. Would like to point out that all of these have this shroud that goes around the top, and this is something that I just, you have to realize I'm kind of a piddler, and I test everything and try everything. And I was using an anemometer testing the flow out of one of the boxes, the early boxes, and I was finding actually negative flow in the corners, not just slowing down, but negative flow. So I started playing with it and realized that if I built a shroud around to cover up the corners, that I'd have pretty much 100% positive flow. And there have been some studies of this and maximizing the size of the shroud for different fans and so on, but they're finding that it increases the performance 30 to 40% to have this shroud on the top. So everyone that I make has a shroud, and it definitely increases performance. But the question is, how long do these filters last? These are electret filters. We know that the rumor is that they decrease in efficiency over time. How much is that? So we tested these new 2 months, 4 months, 6 months, and 10-month filters. Go to slide number 4, if you would. So here is the issue, that two issues. Number one, all of these lines are pretty close together, whether it's 2 months, new 2 months, 4 months, 6 months, or 10 months. They're all pretty close together. There's some drop in efficiency, but it's relatively minor. These are filters that are used 24/7. I don't turn them off. Use them 24/7. It's in offices in a break room that are attached to a factory that manufactures air filters. So it's not the cleanest environment in the world, but they basically continue to perform as MERV 13 filters throughout their life, at least up to 6 months. The MERV, the one at 10 months, that works out to be about a MERV 11. So even that is a very high performance filter. But what I'd like to also point out is that on the bottom, you'll see the scale. It's 0.3 microns to 10 microns. And 0.3 microns, these filters are only pulling out between 40 and 55%. At 0.5 microns, it's 40 and maybe 62%. And as we'll see, that's not what happens when these filters are in use in a Corsi-Rosenthal box. So only in the higher micron numbers, the 5 and 10, are we close to 100%. So here's a Corsi-Rosenthal box with MERV 13 filters, and we compare it to, let's go to slide number 5. Okay, we compare it to a HEPA filter. HEPA filter is 99.97% efficient on particles. That's the lowest efficiency, is at 0.3, and it's 99.97% effective. And if you look on the right, those are HEPA filters. On the left side, those are Corsi-Rosenthal boxes. It's blowing them away. And the sizes, these are all sizes under 1 micron. Every one of these sizes is under 1 micron. So we saw what the efficiency was for MERV 13 filters under 1 micron. It's 40 to 65% or so. But it beats a HEPA filter at 99.97% effective or efficient. How does it do that? Well, what we found out is that it's not just the filter. It's not just filter efficiency. It is filter plus fit. It's got to fit into the system properly. When you use duct tape, it's not real hard to get good fit, but HEPA cleaner, that's very important. And then it's flow. The higher flow is part of the equation. And this is my mission in life, I think, is to try to explain to people that when you have air cleaning, and when your concern is the cleanliness of the air in the room, it doesn't matter what the efficiency of the filter is. End of the day, you want to remove particles in the room, and you have to have flow. You have to move the air to clean the air. That's the critical element. Move the air to clean the air. So it's filter plus fit plus flow, and that's why these things outperform. And this is not just, I've done experiments where I've done it with a MERV 11 Corsi-Rosenthal box, and it outperformed a $1,000 HEPA filter. And it's not just me that has this. I mean, there have been somewhere between 12 and 14 peer-reviewed papers that have been written. Everybody from the people at UC Davis, where Dr. Corsi is the dean of engineering, to University of Connecticut, to EPA, to NIOSH/CDC, and they find exactly the same thing. These Corsi-Rosenthal boxes with MERV 13 filters consistently outperform HEPA filters. So, and it's not, again, it's not just Jim Rosenthal sitting here with his particle counters. I mean, these are peer-reviewed expert papers done by top-notch engineers and scientists.
Jim, we've got to go to halftime and thank our sponsors. When we come back, we're going to go back to these slides and finish this discussion. We'll be right back with Jim Rosenthal, Chairman and Chief Executive Officer of Tex-Air Filters, on the Corsi-Rosenthal Box. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Our association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The Environmental Information Association, EIA's multidisciplinary membership, collects, generates, and disseminates information concerning environmental and occupational health hazards in the built environment at EIA-USA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. The Restoration Industry Association, the oldest and largest nonprofit professional trade association dedicated to providing leadership and promoting best practices through advocacy, standards, and professional qualifications for the restoration industry at restorationindustry.org. Industry sponsors are Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, TSI.com. Tramex Meters, developing modern dynamic moisture meters and humidity monitoring systems since 1974. TramexMeters.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back for the second half of our interview with Jim Rosenthal. Jim, the first time I saw a similar product was at our Healthy Buildings Conference, I want to say back in like 2018. And I noticed Linda Wigington's on here, and she was the first one that showed us. She ran the Roxas Reducing Outdoor Contaminants in Indoor Spaces program, and they were using it primarily, I think, to reduce outdoor contaminants. So if someone had to open a window to get air in, they may not have air conditioning, whatever the case may be, and they're in the Pittsburgh area, which has high outdoor air pollution, unfortunately. They were putting filters on the front of the fan. And you've made a change in that and built these boxes, you and others. I'm wondering what other advances have been made in the design?
There have been a lot. Everything from using true HEPA filters to different types of fans. The United States is relatively unique in the fact that we have pleated filters. They're not readily available in Europe. They're not readily available in Asia, South America. Our market is 80 to 90% pleated filters, and that's the exception. So people in other areas of the world had to come up with new ways of doing it, other ways of doing it. And they were really successful. A lot of those pictures we saw in that little video, they came from Asia and Philippines and the UK. And in fact, there is a Corsi-Rosenthal Foundation UK that is an active group, really great people. They do an excellent job. But that gives you an idea of the penetration of this concept in Europe. I think one of the most interesting things that's happened is the use of PC fans instead of using a box fan. And some real advantages of PC fans. Well, one is they have a lower noise. Instead of running at 50 decibels or 52 decibels, they're running at 40 or less, and you can barely see them, barely hear them. Let's go to number 6, if you would. Okay, so here we have we did some testing to figure out how these PC fans compare to box fans. They're quiet. They do have good airflow, and they use very little electricity. These six fan units that are shown here, the two on the left, they use about 10 watts of electricity. You're using the box fan uses about 50 to 60 watts of electricity, so much less use of electricity. So here's what we did: we built a little chamber. I actually used a vacant room. Created particles in the room, and we compared the efficiency of a HEPA filter, which is the second one from the right, the box fan, Corsi-Rosenthal box, which is the furthest from the right, a 6-fan version with 2 filters, which is the second from the left, and then a 6-fan version with 4 filters. And go to number 7, if you would. So what we did here is we put particles in the room. We used salt. We had a humidifier with a salt solution, which is essentially the same thing that you use in the ASHRAE 52.2 test. And then we had an ambient or a control, which is the normal decay, which is the top blue line. That's where you do nothing in the room over 20 minutes. That's what happens. And then we tested the various versions that I just showed you. What we found that was that the HEPA filter was the worst of all of the ones we tested. That the PC fan with 2 filters was the next, but then the PC fan with six fans, 4 filters was the same as the box fan on low. So to give you an idea, does it work? Yes, it works. You don't feel the same flow, but at least in this test, it showed that they were almost identical in terms of their performance. So I think that gives you an idea of their effectiveness. Okay.
You mentioned the amount of electric they use. I'm just curious, is that one PC fan filter versus a larger filter, or how do those numbers stack up when you start putting 6 of them in a box?
6 is total.
Okay.
That's a total electrical usage.
Okay.
Is somewhere around 10 watts. So very, very, very low usage. And I think we can talk about it a little bit later, but I think there are some ways that we can utilize this low electrical usage to improve the performance of several types of air conditioning systems. So let's go to the next. Let's go to number 8. Okay, a lot of people look at the performance of the air cleaner and say, well, you're really not. We don't really understand how this works. How can you have filter plus fit plus flow? Almost everybody measures particles coming out of a unit. They seldomly measure particles in a room or a chamber environment, a room environment. The one exception to that is in a clean room, where clean rooms are measured on the basis of the levels of particles in the room. They're not measured on the basis of what's coming out of the unit. They do use HEPA filters for clean rooms, but the way they achieve the really low particle levels is through very high air changes per hour. Like an ISO 7 air clean room has a minimum of 60 air changes an hour. Now we're looking at, indoor air. If we can get 6 to 12, we're pretty happy, very, very happy. We can get 6 to 12 air changes an hour. With a clean room, they're doing 60 in order to get the levels that they need. So I decided, multitasking it. I was thinking about this morning. Why do I do all these tests? I do all these tests because every time I get stressed out about something, I'm sitting there at my desk. I'm going, God, this is bad, or that's bad, or we got to do this, or somebody said this on Twitter, or whatever. Whenever I get depressed, I make something, and then I measure it. So I got boxes all over the place that I've been making, and it makes me feel better. So why do I do it? Because it makes me feel better. So anyway, we get this idea of doing a clean room with using a Corsi-Rosenthal box, and I'm going to make my office a clean room. I'm sitting in my office, and if you're familiar with clean rooms, I mean, they control the sources, just 100% control of the sources. You got to wear special gloves. You go into a chamber before you can go into the room. I mean, pressure always has to be right. And here I am in my office. I've got gaps under the doors that are this high. I'm sitting in the office, nothing, no mask on, nothing, and I'm working and getting up and doing stuff. I put 2 of the boxes in the office, turn them on high, and within 15 minutes, we achieved ISO 7 class 10,000 levels of particles. With you saw the efficiencies. And the MERV 13 filters, they weren't HEPA filters, they're MERV 13 filters. And the interesting thing about this chart shows the dramatic drop in particles. Interesting thing about this chart is a lot of people look at those numbers for MERV 13 filters and they say, well, you're getting 40% the first time, and if it recirculates, you get 40% the second time, and you're going to get 40% the third time of that. And you're still going to have all the particles, the smaller particles. That's not what happens. These particles are gone. They are not in the room. They're gone. So the multiple passes, the high airflow dramatically increases performance and gives you, in this case, virtually clean room level particles.
Filter, fit, and flow, huh?
Filter, fit, and flow.
I got really, that one written down.
It applies to everything. I mean, let's take houses or offices. If the air conditioning or heating system is not working and you don't have it on your fan on, you're getting no flow. So how does a MERV 13 filter help at all? It doesn't help. So you have to have the flow. That's the critical thing. You got to move particles to the filter to be able to decrease the particles in the air. And the other thing that any air cleaner will do, but Corsi-Rosenthal Box does it really well. Once the particles are emitted, they're airborne. They are not going to go away immediately. So that means short range transmission, even with a great air cleaners in a room. If you're 24 inches away from somebody, and they cough or they sneeze, there's a pretty good chance you're going to get those particles, no matter how good your air cleaning is. But in a normal situation, what you want to be able to distribute the particles, dilute the particles, and remove the particles. We knew through experience that the transmission rates in outdoor environments were very low. Why was that the case? Exactly what we're talking about here. Diluting the particles into wide open space, distribute the particles. If it was a windy day, those particles are everywhere, even though somebody could be relatively close to you that had a disease. And then you're removing the particles. They're going away. Wind's blowing them away. And the particles move away in all three directions. So it's really important to understand how air cleaners work effectively.
Jim, I've got one more question. Then I want to let Cliff jump in here because he's got a couple good questions for our restoration group. But
sure.
My question is, where should CR boxes be placed in a room? So I'm thinking of school districts, for instance, but it could be a conference room. It could be a meeting room of some type. It could be an office space. Where's the best location? Have you done much work on finding that?
Yeah, basically anywhere, about three feet away from a wall. You can put it in a corner 3 feet away from the wall. And yeah, I have done testing on it. And I've tested relatively large room, about the same size as a classroom, put it 3 feet away from the wall, had them running for an hour, did particle counts in all four corners. And the particle counts were within 5% of the particle counts near the box. So what that means is that it's distributing the air, and clean air moves out just like dirty air. We think, smoke in a room, it fills everything up eventually. And it's the same thing with clean air. It's gonna move out as well. So you need to have enough flow and enough air changes an hour, but essentially anywhere in the room where you have good flow into all four sides of the filter of the system is going to be okay.
And in a typical schoolroom, 600 to 1,000 square feet, how many boxes is it going to take? And is this on low, medium, or high?
Yeah, and those are the questions. I mean, how many people in the room? I mean, that's as we saw in ASHRAE 241, they're basing all of their performance numbers on the number of people in the room, how many CFM of air that you need. So it's hard to say, just say you absolutely need this or that. Depends upon the conditions, what speed you're going to run it at. Generally, what we found is 2 air cleaners in a classroom running on low is going to be sufficient. If it's a larger classroom, like 1,000 square feet, you're going to need 3. That's going to give you somewhere around 5 to 6 air changes an hour. That's a rule of thumb. I mean, there are all kinds of other variables that can be thrown into that. Most important thing is to keep them on. Keep the air cleaners on, running. So often people, even in my own building, I put them in the break room. I go in there and every other week I have to turn it back on again because somebody's decided that they don't want to have it going. And that's one of the advantages of these PC fan air cleaners is that there's no noise, very little electrical usage, very low noise. As I've explained to you guys, I have one running with 6 fans 6 feet away from me right now, and you can't hear it. And the idea is you just leave it on, just let it go 24/7, and that is going to dramatically increase compliance. More people are going to be using them because of the lower noise factor.
Cliff, let me let you jump in here just in case we didn't get to some of the questions you want. We'll go to roundup in a minute.
Yeah, I've got a couple actually.
Okay.
I guess the first one dealt with we had the East Palestine train wreck occurred about 30 miles away from Pittsburgh, and we had calls from consumers seeking advice. And have you given any consideration to adding absorption capability to your devices? And if so, how would you do it? And is there anything that you would suggest, if you were receiving those calls, what you would advise people to do?
Yeah, we've done some research into it. If we go to slide number 9, we've actually made boxes using carbon pleated media, carbon pleated filters. Here's one right here. They work well. It depends upon the chemical, though. Carbon it adsorbs, but it likes some chemicals better than others. So some chemicals it's not going to be able to pull out. You'd have to really know and look at the type of carbon and then have some idea of how the efficiency is. So I couldn't really tell you off the top of my head whether or not it would be effective on that particular mixture, but generally it's going to work. The problem that you have is that carbon loads up. It's not like a filter that loads up and just keeps getting more efficient or working. It continues to work at a high level. So you don't have enough carbon. I've looked at the idea of using one of the panels as a granular carbon tray,
right,
where you're using granular carbon,
right.
And I think that probably has the best potential. 2 or 3 of the panels would be for airflow and particle removal, and then 1 or 2 of the panels could be a granular tray, and I think that probably could work, and it would give you a longer life. The problem is smoke is the same way. It doesn't last very long because there's not enough carbon to be able to adsorb a lot of the chemicals that are in the air.
Okay. I guess next question we get a lot is wildfires.
Right.
And could these certainly these devices would be effective in a wildfire.
Yeah.
Same issue. So they would remove the particles very, very effectively,
right.
Are not going to be real effective on removing the odor. However, it would seem to me that East Palestine probably had a greater odor problem than people would have had,
right.
Following wildfires. I guess the third one is.
You want me to answer that one, or?
Yeah, go ahead. I'm sorry.
Okay, so the EPA did a really nice study on efficiency of air cleaners on wildfire smoke. Mm-hmm. And they found that the Corsi-Rosenthal box did an extraordinarily good job, better than anything else. And then they also found that it decreased in efficiency over time. And there have been some articles written about that, saying that the electret filter was destroyed by the wildfire smoke. You have to realize that the level of smoke in the chamber when they were doing these tests was from a fire. They literally created a small fire in the room, had a huge amount of smoke. And yes, there was a decrease in efficiency of the electret filters. But by the same token, we change filters in schools all the time where there's a fire in the laboratory or the chemistry laboratory. Mm-hmm. You have to change every filter because every filter smells. They emit odors because they've captured odors. They're not as good as carbon at capturing odors, but they are capturing odors. And I would say that every filter that was used in that chamber needed to be replaced. So yes, you can decrease. You definitely can decrease particles. Huge amount of decrease in particles. Highly recommended. Close the windows, close the doors. Use an air cleaner, reduce the particles, and then if you can get some carbon on it, it's going to help on the odor part. But then you need to get rid of the filters. So even if like in school districts, they'll have the filters in there during wildfire season. They need to take them out, even if there's some life left in it, because what's happened is you've captured the chemicals in the media. And that as the air goes over those filters, it's releasing those chemicals back into the air and into the breathing zone of the people inside the school or whatever. So yeah, I mean it's a good way to protect against wildfire smoke, but you have to be cognizant of the fact that you often have to replace the filters depending upon the exposure level.
Okay, last question. It's kind of a scary question, but what would happen, or do you think these CR boxes would provide protection in the event of a dirty nuclear bomb or bioterrorism?
There was a study done on this 15 years ago or something, and they found that these bioterrorism, it's particles. The filter doesn't care what particles they are. I mean, it's going to pick up a pretty high percentage of the particles that are in the air, no matter what the source, whether it's a bioterrorism device or it's a wildfire or it's you're breathing COVID in the air. I mean, it doesn't care. In fact, one of the things that we found out was that Brown University did a study. They found that Corsi-Rosenthal boxes reduced PFAs and phthalates by 40 to 60% in the environment, in where it was tested. These are SVOCs. How is that possible? The way it's possible is that those chemicals that are known dangerous pollutants attach to particles, and the particles are captured in the fibers of the filter. That's how it's possible.
Let's go to the roundup. All right, the roundup is brought to us by Tramex Meters today. And by the way, next week we'll have Jim Stanley on from Tramex Meters and maybe a few of the other moisture monitoring experts from Tramex. Looking forward to that. Real quick, Jim, I wanted to mention that Linda Wigington, by the way, that was 2015. Thank you, John, that I saw Linda demonstrate her filter with the fan with a filter on it. She said we were using fan filters both in windows and also with 4-inch MERV 13 filters as a fan filter in indoor spaces. In residential application, we had excellent performance measured with the Dylos particle monitor, but they do not recommend using anything other than the 4-inch filter. It is a 1-to-1 fan filter. I'm not sure. I don't quite understand it, but does that make sense to you, Jim?
Yeah, they're using a 4-inch filter on the box fan. And
yeah,
that was one of the first things I tested when the reporter from Wired called. I did a 1-inch, a 2-inch, and a 4-inch, and 4-inch is definitely better. I don't remember the exact numbers, but I think it was something like the 4-inch gave us like a flow of 460 cubic feet per minute, and the Corsi-Rosenthal box up to about 580. So
we may run a little over here. Do you have to run?
No.
Okay.
I hope you're enjoying it. I'm enjoying it.
I am.
To talk, and I'm a happy man.
I've got two more questions here that I definitely want to get to. One is, by the way, before we go to that, what's the price difference on a 2-inch and a 4-inch filter?
It's pretty substantial. I mean, it's a lot more media area, so it's more than twice, I think. I mean, I'm not really sure. I don't really know off the top of my head, but it's definitely considerably more expensive.
And I'm curious, how much has have your orders changed over the last few years with respect to either, a 1-inch filter with a lower MERV rating versus the 2-inch filters with the MERV 13? I assume you're selling more 2-inch with the MERV 13 now, but you tell me.
Well, in commercial, for a long time, 2-inch filter has been the predominant filter. And in residential, 1-inch filter has been predominant. What we are seeing is people moving to thicker filters. And that's my blanket recommendation for any consumer that's concerned about airflow in their system. Go to a 4-inch filter. That can be a 4-inch, like commercial 4-inch filter that's relatively inexpensive, or you can go with a Honeywell or Air Bear or any of these other deeper, thicker filters. They all give you much more surface area and better performance. So we have seen an increase in those. Not a lot of increase in residential and 2-inch.
And I spend a lot of time these days in gyms, especially like wrestling and MMA gyms, and there's people close together, and they're a little tough on. I put a CR box in one gym. It got pounded so bad I had to take it out. It was been up pretty good by the end of about a month. My thought was, why wouldn't I take that and hang it from the ceiling with the fan pushing air down so that we captured air? And then also when we're in the heating season, we might, bring a little more heat back down. Does that seem like a good idea to you? Is it something that's been tested?
I've not tested it, but other people have done it. I've seen things on Twitter where people have put them up high and trying to save some space on the ground. And theoretically, it's going to work because you're moving air in the space and you're recirculating air in the space, and it's going to keep going through the filters. Could we go to slide number 10?
Sure, John.
I have an interesting idea. So this is a PC fan box that I made using. These if you see over on the left side on the bottom, these are panels they're modular 3-fan panels, and the filters are 16 by 20. You literally build a box with 4 16 by 20 filters, stick those panels in, and plug it in. I mean, it's a 10-minute build, and it has 300 CFM, uses 10 watts of electricity. And when I saw this question that you sent to me, same question, and I think something like this in an area where you have these mini splits that have the world's worst filters that are basically window screens. Yep. You could have these running 10 watts of electricity. So you're still accomplishing the much lower energy usage, but you're dramatically increasing the safety of the air inside the room where the mini split is being used. And you could even, somebody smarter than I could figure this out, maybe have a duct going outside so that you're drawing air in, so that you have ventilation air. Mm-hmm. And where you have a mini split, ventilation air, and cleaning the air in the room. I mean, it seems like a wonderful combination. Of course, this would be up in the air as well, up by the mini split. Have it maybe even part of the unit or something. But the mini split system is a problem. It's getting very poor filtration. One of the questions we had was the fact that there might be transfer going to the unit of viral particles. And one of the first studies was done in China in a restaurant. You might remember this. Yeah. And that system, very poor ventilation in the restaurant, but that system was a mini split. So you had the return and the supply in the same unit. And you basically had this path of return and supply going over the same unit. And if you had something like this, you're removing the particles, you're distributing the particles, and it would really help the indoor environment, and make the mini split a much better, safer product for indoor air quality.
Jim, one of the pushbacks that people get when they go to schools and other places and talk about the Corsi-Rosenthal box is the safety of putting a fan on top of a bunch of filters. Are we going to have a fire? Are we going to have this? We're going to have that. I wonder if you could address that topic for a minute.
Sure. UL was commissioned by the EPA to do a study on exactly that point, because a lot of people were using filter in a box fan for wildfire smoke. They did the study and they found that they checked a number of different fans, but and a number of different resistance levels, even totally covered the heat from the fan was still within UL limits. It still passed the UL test. So in essence, that's been tested and is not there's not been a problem. Also, any new fan has a fuse in the plug. So if there were an issue, if there was a short, that system's going down immediately because of the fuse in the plug. So that's the reason why you use newer fans. You don't want to take a fan that's been sitting in the garage for 20 years and make a Corsi-Rosenthal box with it. Use a newer fan. It's much safer. So yeah, it's an issue, and I think it's been addressed, but it comes up all the time. School districts ask the same question. I will say, out of all the thousands of these that have been made, there's not one instance of there ever being a problem with overheating for the fan. Not one. Which
in your estimate, how many of these do you think are out there now?
I think 200 to 250,000. And that takes in the whole world. I mean, and literally it's worldwide. I remember one time I got a call from ASHRAE Brazil to do a talk for their annual meeting. And I did a talk through Zoom for the ASHRAE Brazil group, and two people got up and said, I just want to thank you for creating this because I've been using it in my home and it really works well. Just unsolicited and out of that group in Brazil. So I think it's safe and it's being used worldwide. And if you're using certainly the box configuration, there's very little strain on the motor. We've done tests. We found that the pressure drop at the filter is about 1/10 of the pressure drop that you'd have with the same velocity in an HVAC system. 1/10.
That's fascinating. Jim, before we go, two things. One, can you give us the website for the Corsi-Rosenthal Foundation?
Yes, it's on one of those slides. I think it's number 10, Corsi-Rosenthal
There it is.
Corsi-Rosenthal Any support, volunteers, monetary would be greatly appreciated. We have added a lot of really good information on the website, directions on how to make them, stories about people using them, a lot of data of how effective they are. It's definitely worth going out to. Corsi-Rosenthal Foundation.org.
We'll make sure we get that in the blog and make it prominent for people to look at. Jim, before we go, we always give you the last word. Is there anything we missed? I know you had some slides. I don't know if we missed one that you wanted to make sure we covered, or if there's any other question or comment you have before we go.
No, I wasn't going to talk about 241, but I'll probably leave that for other. Let me discuss 241.
Go ahead. That was my last question. I kind of didn't know whether you wanted to touch on it or not. Good.
Okay. It is really almost revolutionary in two respects. One, it got passed really quickly. I mean, the standards in ASHRAE take years. This was done in 6 months. And my hat's off to Bill Bonfleth and all the people on that committee. It's just an unbelievable job. And by and large, I think it's a great standard, and it's something that can really help controlling infectious aerosols. For some reason, they included in the air filters that in order to get credit, you either had to have Appendix J or MERV A filters or ISO 16890. Neither one of these have been passed by the ASHRAE 52.2 committee. And there are reasons why they were not passed. They have some serious flaws, and for some reason that was included. I'm working on trying to get that reversed, and probably the biggest problem is 80 to 90% of America is not going to be able to comply with the filter requirements of ASHRAE 241 because there are no pleated filters that are MERV 11 or MERV 13. They're not available. we've been trying for 20 years to try to develop something that without electret that gives that same performance, but they're not available. So it's really strange to have a standard where most people cannot comply. Most buildings cannot comply. And what worries me is that because you can't comply, we're going to go with a filter that is much less efficient on those exact same particles that you're trying to remove, the infectious aerosols. If you go to a MERV 8 mechanical filter instead of a MERV 13 or a MERV 11 electret filter, you're essentially letting all those particles remain in the air. They're very inefficient on the small particles. 0.3 to 1, they're less than 10% effective. So you have somebody in California, same thing with wildfire smoke. Somebody in California, wildfire, they have MERV 8 filters, mechanical filters in their system. All that wildfire smoke, the smallest particles, most dangerous particles, are going in the students' lungs. That's what worries me, is that because you cannot comply, you go to a much less effective filter, and that causes some real problems.
Jim, I want to thank you from the bottom of my heart for joining us here. It's been a great show, and also for all the great work you and Rich have done. And I know folks probably wonder why Rich wasn't here. Unfortunately, he couldn't make it. He had a rebound of COVID that has him pretty banged up at the moment, but I know he would love to have been here, and I hope he's listening in and he gets well soon. This is Radio Joe Hughes saying thanks to this week's guest, Jim Rosenthal, Executive Officer of Tex-Air Filters. Also want to thank my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Most importantly, our growing loyal audience and our sponsors. I also want to mention next week we've got Ryan Stanley, the head of Tramex Monitoring UK. We're going to do a deep dive into moisture monitoring, and I think we may also have another Tramex person or two in that show. So come back and join us next Friday at noon for the next episode of IAQ Radio Plus.
Thanks, Joe.
For IAQ Radio, I'm Spike Reel saying thanks for listening.